We'll do the same thing. We can still calculate it in Excel, so we'll just recalculate the second order term, and we'll still plot the exact value, red, and we'll plot yellow as being this new improved version. The blue was the original one, the original Euler's approach. Well, now that I'm looking at that graph, I don't think I'm happy still, because the yellow curve, although it did a little better, it didn't do much better. And man, what do I need to do? Go after a third order term or a fourth order term? That could get to be kind of cluttered, and it doesn't seem to be very hopeful on doing well enough. Well, this is the problem. We're having the same problem that we had with one-sided derivatives. Remember back in chapter 4, we noticed that if you use the traditional one-sided calculation for a first derivative, you're really kind of biasing yourself to one side. You're trying to claim that the derivative at x is a function of x and x plus h. It might have been better if you went to x plus h and x minus h to get less error into the equation. Or we're trying to make that secant line that you get from the definition of a derivative closer to the actual tangent line. Now that worked in chapter 4, and we came up with what we called a central difference method. And we're going to need to do something similar here. We'll move that over to a job for section 7.2. Okay, but that said, we do owe a little bit of practice on Euler's method, and we could do that in the form of a homework. So go to your book and go to chapter 7.1 or section 7.1. Pull out problem number 5 of the computer exercises. So that's the second section of the exercises. And just do what it tells you to do. Your A is going to be 0. Your B is going to be 1. I'd like you to break the interval into 100 pieces. And that is going to give you a step size of 0.01. So go ahead and write your MATLAB code. And you've got your parameters. And run that thing off and see what you get. And as usual, calculate the normal parameters we like and comment your code and do the proper indenting, and we'll see where that goes. So we'll do that, and then we will come back into section 7.2 and see if we can't do a better job improving on Euler's method and increasing the accuracy of numerical methods when we're solving first order differential equations.